You ever stop and wonder how all this automation around us actually works? I mean, how do the machines on a factory floor, or hey, even just the automatic door at the grocery store, actually perceive the world? Well, it's not magic, but man, it's pretty close. So let's dive in and uncover the secret senses of machines.
Seriously, think about that automatic door for a second. You walk up, your hands are full, and whoosh, it just opens. It's so smooth, you'd swear it read your mind. But what's really happening there? How does a chunk of glass and metal know you're about to walk through it?
Well, the secret isn't magic at all. It's a whole array of powerful and pretty clever electronic senses. So for the next few minutes, we're going to pull back the curtain and see exactly how these things give machines the ability to touch, see, and even detect things that are totally invisible to you and me. All right, so let's kick things off with the most intuitive sense there is: touch. For machines, this is all about knowing something's there by physically bumping into it. It's the most straightforward, no-nonsense way for a machine to get a confirmation. Direct, simple, and, incredibly reliable. And the absolute hero here is the good old contact switch. Just picture it. A part moves down an assembly line, it gets into position, and it physically presses a little button. There's no guesswork, no maybe. The machine knows with 100% certainty that the part is there because it can feel it. That pure simplicity is what makes it so rock solid.
Okay, but what happens when you can't actually touch the object? Maybe it's red hot, or super delicate, or just moving way too fast. That's when we need a machine's sense of sight. And what's really cool is that a lot of the time, this sight uses light that we can't even see.
For all the complex ways they're used, the basic idea behind these is shockingly simple. Every single optical sensor comes down to two things: an emitter, which is basically a tiny focused flashlight, and a detector, which acts like an eye. The machine knows something's in the way when an object either breaks that beam of light or bounces it back to the eye. That's it.
So you've got two main ways to set this up. First is what's called opposed mode, where the emitter and detector are separate. They create an invisible tripwire, literally like a laser grid in a heist film, right? Then there's the more common way, retroreflective, where the flashlight and the eye are in the same box and they just bounce a beam off a little reflector. Either way, the logic is the same. If the beam gets broken, something's there.
Now, that retroreflective sensor has a really awesome trick up its sleeve. It uses polarized light, kind of like your fancy sunglasses. The special reflector actually flips the polarity of the light, so the sensor knows for sure it's seeing its own beam and isn't being tricked by, say, a shiny piece of metal passing by. And then you have the absolute simplest of them all, the diffuse sensor. This one doesn't even need a reflector, it just bounces light right off the object itself. It's super easy to set up, but its performance can be a bit tricky depending on if the object is dark, light, shiny, or dull.
All right, so we've got touch and we've got sight. But now let's get into something a little more out there. We're talking about a technological sixth sense. These are the sensors that can find things without any light and without any physical contact, just by sensing a disturbance in an invisible field.
And this sixth sense really comes in two main flavors. First up, the inductive sensor. Just think of this as a tiny, super focused metal detector. It puts out a magnetic field and it can only see metal. Then you've got the capacitive sensor, which I like to call the everything detector. It uses an electric field and it can sense pretty much any material you can think of: plastic, liquid, wood, you name it. So how does that metal detector one actually work? Well, it generates this magnetic field from a coil of wire. When a piece of metal gets close, the field creates these little tiny electrical whirlpools inside the metal itself. The sensor picks up on that tiny disturbance and boom, it knows instantly that there's metal in front of it. And the everything detector, the capacitive sensor, it creates an electric field. And anything that enters that field, doesn't matter if it's metal or plastic or liquid, changes the properties, the capacitance of that field. Its versatility is just amazing. It's how a machine can, say, see the level of grain inside a totally solid silo, or check if a bottle is full without ever opening it. Okay, this is all great. The sensor has detected something, now what? How does it actually report back to the mothership, to the machine's brain, the PLC? How does it speak its incredibly simple language of, yes, there's something here, or no, there's not? And believe it or not, this is a much bigger challenge than you'd think. A factory floor is an unbelievably noisy place. Electrically, I mean. You've got massive motors spinning up, high-power gear everywhere, all of it creating a storm of interference. So how do you get a tiny, clean signal through all that chaos? Well, you definitely don't do it with voltage. Trying to send a voltage signal in a factory is like trying to whisper to your friend across a roaring rock concert. It's just going to get drowned out. Instead, these sensors use electrical current. And that's not a whisper. That is a firm, unmistakable handshake. It's a signal that cuts right through all that background noise.
And this handshake can happen in two ways. You've got a sourcing or PNP sensor, which basically pushes current out to send its signal. Then you have a sinking or NPN sensor, which does the opposite. It pulls current in to complete the circuit. But honestly, whether it's pushing or pulling, it doesn't really matter. The end result is the same. A crystal clear, noise-proof on signal gets delivered to the brain.
So let's wrap this all up, shall we? Machines have these incredible senses that are a lot like ours. They can touch with super reliable contact switches. They can see with optical sensors using beams of light. They've even got that sixth sense using inductive sensors for metal and capacitive sensors for, well, pretty much everything else. And crucially, they have a language using the firm handshake of electrical current to speak clearly through all the noise. And here's why this is so cool. This stuff used to be crazy expensive, super specialized tech. But now, these sensors are cheap, they're tiny, and they're being put in everything. This is how our world is getting smarter. It's why we have responsive homes, safer cars, and more efficient cities. So as these tiny senses keep getting cheaper and more powerful, you've got to wonder, what everyday object is going to be the next one to wake up?